I am the virtual teacher instructor for construction electrician course at Egnatia Career College. This is video number 5. In this chapter we will learn conductor sizes and types, wiring methods, wire connections, voltage drop, and neutral sizing for services. All references to conductors are for copper conductors, unless otherwise stated. Wire size. The copper wire used in electrical installations is graded for size according to the American Wire Gauge (AWG) standard. The wire diameter in the AWG standard is expressed as a whole number. AWG sizes vary from fine, hair-like wire used in coils and small transformers to very large diameter wire required in industrial wiring to handle heavy loads. The wire may be a single strand, solid conductor, or consist of many strands. Each strand of wire acts as a separate conducting unit. Conductors that are number 8 AWG and larger generally are stranded. The wire size used for a circuit depends on the maximum current to be carried. The Canadian Electrical Code, CEC, states that the minimum conductor size permitted in house wiring is number 14 AWG. Ampacity. Ampacity is defined as the current in amperes a conductor can carry continuously under the condition of use without exceeding its temperature rating. This value depends on the cross-sectional area of the wire. Since the area of a circle is proportional to the square of the diameter, the ampacity of a round wire varies with the diameter squared. The diameter of a wire is measured in mils. A mil is defined as 1/1000th of an inch, 0.001 inches. A circular mil is the area of a circle that is 1 mil in diameter. The circular mil area, CMA, of a wire determines the current carrying capacity of the wire. This can be expressed as a formula. CMA equals diameter squared. Therefore, the larger the CMA of a wire, the greater its current carrying capacity. AWG sizes are also expressed in mils and range from number 40, 10 circular mils, to number 4, 211 600 circular mils. Wire sizes larger than 4 are expressed in circular mils only. Since the letter K designates 1000, large conductors, such as 500,000 circular mils, can also be expressed as 500 kc mils. However, many texts and electricians continue to use an older term, MCM, in which the first M is a Roman numeral representing 1000. Thus, 500 MCM also means 500,000 circular mils. Conductors must have an ampacity not less than the maximum load they are supplying. All conductors of a specific branch circuit must have an ampacity of the branch circuit's rating. There are some exceptions to this rule, such as taps for electric ranges. Ampacities are reduced if the conductors are installed in areas of high ambient, surrounding temperature. Ampacities are also reduced when there are more than 3 conductors in a raceway or cable. Circuit rating. The rating of the overcurrent device, OCD, and the ampacity of the wire must be compared. The branch circuit ampacity rating is the lesser of these two values. Aluminum conductors. The conductivity of aluminum wire is not as great as that of copper wire for a given size. For example, a number 8 90 degrees Celsius copper wire has an ampacity of 55 amperes. Aluminum wire has a significant weight advantage, but a number 8 90 degrees Celsius aluminum wire has an ampacity of only 45 amperes. It is important to consider resistance when selecting a conductor for a long run. An aluminum conductor has a higher resistance than a copper conductor for a given wire size, which therefore causes a greater voltage drop. Voltage drop is equal to amperes times resistance. Although aluminum conductors are approved for branch circuit wiring, they are seldom used for this application. They are, however, widely used in such applications as apartment feeders and utility distribution systems. They are also found on such equipment as ballasts and luminaires. Common connection problems. Problems often arise with aluminum conductors that are not properly connected as follows. A corrosive action is set up when dissimilar wires come into contact with each other, especially if moisture is present. The surface of aluminum oxidizes as soon as it is exposed to air. If this oxidized surface is not broken through, a poor connection results. When installing aluminum conductors, particularly in large sizes, you must brush an inhibitor onto the aluminum conductor and scrape the conductor with a stiff brush where the connection is to be made. Scraping the conductor breaks through the oxidation, and the inhibitor keeps the air from coming into contact with the conductor, preventing further oxidation. Aluminum connectors of the compression type usually have an inhibitor paste factory installed inside the connector. Aluminum wire expands and contracts more than copper wire for an equal load, another possible cause of a poor connection. Crimped connectors for aluminum conductors are usually longer than those for comparable copper conductors, resulting in greater contact surface of the conductor and the connector. Proper installation procedures. Proper, trouble-free connections for aluminum conductors require terminals, lugs, and/or connectors that are suitable for the type of conductor being installed. Terminals on receptacles and switches must be suitable for the conductors being attached. Listed connectors provide proper connection when properly installed. Wire connections. When splicing wires for connecting to a switch, fixture, circuit breaker, panel board, meter socket, or other electrical equipment, you must twist the wires together and then use a wire connector. Wire connectors are known in the trade by such names as screw terminal, pressure terminal connector, wire connector, wing nut, wire nut, scotch lock, split bolt connector, pressure cable connector, solderless lug, and solder lug. Solder-type lugs are not often used today. In fact, connections that depend on solder are not permitted for connecting service entrance conductors to service equipment. The labor costs make the cost of using solder-type connections prohibitive. Solderless connectors, designed to establish connections by means of mechanical pressure, are quite common. As with the terminals on wiring devices, switches and receptacles, only wire connectors marked AL may be used with aluminum conductors. This marking is found either on the connector itself or in the shipping carton. Connectors marked ALCU are suitable for use with aluminum, copper, or copper-clad aluminum conductors. Connectors not marked AL or ALCU are for use with copper conductors only. Conductors made of copper, aluminum, or copper-clad aluminum may not be used in combination in the same connector unless the conductor is specially identified for the purpose either on the connector itself or on, or in, the shipping carton. The conditions of use will also be indicated. Such connectors are usually limited to dry locations. Temperature considerations. Conductors are also rated for the temperature they can withstand. For example, Type TWN 60 degrees Celsius, Type TWN 75 degrees Celsius, Type T90 nylon 90 degrees Celsius, Type RW 90 degrees Celsius. Conductors with TWN 75, T90 nylon, or RW90X LPE insulation are the types most commonly used in conduits because their relatively small size makes them easy to handle and allows more conductors in a given size of conduit. The last two conductors are rated for 90 degrees Celsius so they can be used in high temperatures, such as those found in attics, near recessed light fixtures, and around cables buried in insulation. The most commonly used cable is NMD90, a non-metallic sheath type. Easy to handle, it is rated for 90 degrees Celsius. The permitted ampacity of all 90 degrees Celsius rated conductors used in sealing light outlet boxes is reduced to that of 60 degrees Celsius rated conductor. Neutral size. The grounded neutral conductor is permitted to be a smaller AWG than the hot ungrounded phase conductors, L1 and L2. Only if it can be proved that all three service entrance conductors are properly and adequately sized to carry the loads computed. Some utilities may not permit the reduction of the service neutral for services of less than 200 amperes. Therefore, check with the local utility and inspection authority before proceeding. The neutral conductor shall have sufficient ampacity to carry the unbalanced load. And the maximum unbalanced load shall be the maximum connected load between the neutral and any one ungrounded conductor. In this residence, a number of loads carry little or no neutral current, including the electric water heater, electric clothes dryer, electric oven and range, electric furnace, and electric air conditioner. Thus, we find logic in the CEC, which permits reducing the neutral size on services, feeders, and branch circuits where the computations prove that the neutral will be carrying less current than the hot phase conductors. Voltage drop. Low voltage can cause lights to dim, television pictures to shrink, motors to run hot, electric heaters to produce less than their rated heat output, and appliances to operate improperly. Low voltage in a home can be caused by wire that is too small for the load being served, a circuit that is too long, poor connections at the terminals, conductors operating at high temperatures having higher resistance than when operating at lower temperatures. A simple formula for calculating voltage drop on single-phase systems considers only the direct current, DC, resistance of the conductors and the temperature of the conductor. The more accurate formulas consider alternating current, AC, resistance, reactance, three-phase installations, temperature, and spacing in metal conduit and in non-metallic conduit. The simple voltage drop formula is more accurate with smaller conductors, but loses accuracy as conductor size increases. It is sufficiently accurate for the voltage drop calculations necessary for residential wiring. Voltage drop formula is ED equal to K times I times L times 2 divided by CMA. Rule 8-102 states the maximum allowed voltage drop percentages. The voltage drop shall not exceed 3% in any feeder or branch circuit and 5% overall. This figure explains the requirements for a voltage drop that involves both the feeder and a branch circuit. Caution using high-temperature wire. When trying to use smaller conduits, be careful about selecting conductors on the ability of their insulation to withstand high temperatures. Always calculate a voltage drop when your decision to use the higher temperature rated conductors was based on the fact that the use of smaller size conduit would be possible. Select the proper size of conductor to use for the job according to the load requirements and then complete a voltage drop calculation to see that the maximum permitted voltage drop is not exceeded. Here it is one example. What is the approximate voltage drop on a 120-volt, single-phase circuit consisting of number 14 AWG copper conductors where the load is 11 amperes and the distance of the circuit from the panel to actual load is 25.9 meters? Solution: 5.46 volts drop. Here another example. Find the wire size needed to keep the voltage drop to no more than 3% on a single-phase 240-volt circuit that feeds a 44-ampere air conditioner. The circuit originates at the main panel, which is located about 19.8 m from the air conditioner. No neutral is required for this equipment. Solution: 9,535 circular mils minimum. If you compare the calculation of voltage drop to the size of the wire or current, note that the larger wire gauge was from the current calculation. If the voltage drop calculation required a larger wire than the current table, the larger wire is always installed. Approximate conductor size. Rule 1. For wire sizes up through 0000, every third size doubles or halves in circular mill area. Rule 2. For wire sizes up through 0000, every consecutive wire size is about 1.26 times larger or smaller. A number 3 AWG conductor is about 1.26 times larger than a number 4 AWG conductor. Here one example about what are the approximate CMA and resistance of a number 6 AWG copper conductor. When the CMA of a wire is doubled, its resistance is cut in half. And inversely, when a given wire size is reduced to 1/2, its resistance doubles. Calculation of maximum length of cable run. Using Table D3. CEC table gives a method of calculating the maximum length of a 2-wire circuit. According to Rule 8-102-1, this may be either 2% or 3%. It considers AWG of the wire, current on the wire, load, distance of the conductor run, example, 10 am from panel to outlet, rated conductor temperature, percentage of allowable ampacity, type of conductor, CU or AL, Table D3, Note 5, percentage voltage drop on feeder or branch circuit, 2% or 3%, voltage applied to circuit. You can use the following formula to find the maximum length of a run of wire using Table D3. There are 2 formulas here. L maximum length of 2-wire CU conductor run in meters. And percent allowable ampacity. Example. What is the maximum distance that a number 10 2 nMWU copper wire circuit may be run from the panel if it is carrying a load of 18 amperes at 240 volts with a 3% maximum voltage drop? Answer: 50.08 meters. Non-metallic sheathed cable. Non-metallic sheathed cable is a factory assembly of 2 or more insulated conductors having an outer sheath of moisture-resistant, flame-retardant non-metallic material. This cable is available with 2, 3, or 4 current-carrying conductors, ranging in size from number 14 through number 2 for copper or aluminum. 2-wire cable contains 1 black conductor, 1 white conductor, and 1 bare bonding conductor or green insulated conductor. 3-wire cable contains 1 black, 1 white, 1 red, and 1 bare bonding conductor or green insulated conductor. The Canadian Standards Association (CSA) lists 3 classifications of non-metallic sheathed cable. Type NMD90 has a flame-retardant, moisture-resistant non-metallic covering over the conductors and is suitable for both dry and damp locations. Types NMW and NMWU have a flame-retardant, moisture-resistant, corrosion-resistant, fungus-resistant non-metallic covering over the conductors. NMWU is designed especially for use in wet and direct burial locations. Electricians once referred to non-metallic sheathed cable as Romex or Lomex. Non-metallic sheathed cable has an uninsulated copper conductor that is used for bonding purposes only. This bonding conductor is not intended for use as a current-carrying circuit wire. Equipment bonding requirements are specified in Rules 10-600 through 614. These rules require that all boxes and fixtures in the residence be bonded to ground. This table lists the sizes of the bonding conductors used in cable assemblies. Note that the copper bonding conductor shown is a smaller size than the circuit conductors for 20 and 30 ampere ratings. This other table shows the uses permitted for Type NMD90 and Type NMW and NMWU cable. Refer also to conditions of use in CEC Table 19. Installation. Non-metallic sheathed cable is the least expensive of the wiring methods. It is relatively light in weight and easy to install. It is widely used for dwelling unit installations on circuits of 300 volts or less. The installation of all types of non-metallic sheathed cable must conform to the requirements of Rules 12-500 through 526. The cable must be strapped or stapled not more than 300 mm from a box or fitting. The intervals between straps or staples must not exceed 1.5 meters. The cable must be protected against physical damage where necessary. The cable must not be bent or stapled so that the outer covering or the wires are damaged. The cable must not be used in circuits of more than 300 volts between conductors. Wherever non-metallic sheathed cable is less than 1.5 meters above a floor, Rule 12-518 requires that the cable be protected by rigid conduit, EMT, or other means. A fitting, bushing, or connector must be used at both ends of the conduit to protect the cable from abrasion, Rule 12-906. A metal conduit must be bonded to ground. When cables are bundled together for distances longer than 600 millimeters, the heat generated by the conductors cannot easily dissipate. These conductors must be derated according to CEC Table 5C. When non-metallic sheath cable is run close to a heating source, an air space must be maintained to minimize the transfer of heat to the cable, Rule 12-506-4. The spacing requirements are 25 mm to heating ducts, 50 mm to masonry chimneys, 150 mm to chimney and flue cleanouts. The spacing may be reduced if an approved thermal barrier is placed between the conductor and the heat source that will maintain an ambient conductor temperature of 30 degrees Celsius. This figure shows the CEC requirements for securing non-metallic sheathed cable. Rule 12-514 states how non-metallic sheathed cable must be run in unfinished basements. Rule 10-612-3 requires that all metal boxes for use with non-metallic cable must have provisions for attaching the bonding conductor. This figure shows a gangible switch device box with a bonding screw by which the bonding conductor may be connected underneath. Armored cable. The CEC describes the construction of armored cable. It lists three types: AC90, commonly called BX, ACWU90, and TECK90. AC90 is approved for dry locations only. At one time, BX was a trademark owned by the General Electric Company. It is now a generic term. Armored cable is an assembly of insulated conductors in a flexible metallic enclosure. Armored cable may be used in a variety of locations depending on the type of jacket on top of the armored cable and the location for the cable. All three types may be used for a service entrance above grade in dry locations, but ACWU90 and TECK90 are approved for service entrance. Armored cable is generally available with 2, 3, or 4 conductors in sizes from number 14 AWG to 2000 kmil inclusive. 2 wire equal 1 black, 1 white plus 1 bare. 3 wire equal 1 black, 1 red, 1 white plus 1 bare. 4 wire equal 1 black, 1 red, 1 blue, 1 white plus 1 bare. Armored cable must have an internal bonding wire of copper or aluminum to meet the bonding requirements of the CEC. Use and installation of armored cable. Armored cable can be used in more applications than non-metallic sheathed cable. Rules 12-600 through 618 govern the use of armored cable in dwelling unit installations. AC90 and TECK90 armored cable may be used on circuits and feeders for applications of 600 volts or less. May be used for open and concealed work in dry locations. May be run through walls and partitions. May be laid on the face of masonry walls and buried in plaster if the conductors are not larger than number 10 AWG and used for the extension of existing outlets. Must be secured within 300 mm of every outlet box or fitting and at intervals not exceeding 1.5 meter. Must not be bent so that the radius of the curve of the inner edge is less than 6 times the external diameter of the cable. Must have an approved fiber or plastic insulating bushing and tie short at the cable ends to protect the conductor insulation. Armored cable, types ACWU90 and TECK90, is approved for use in these situations. Underground installations. Burying in masonry or concrete during construction with minimum 50 mm of covering. Installation in any location exposed to weather. Installation in any location exposed to oil, gasoline, or other materials that have a destructive effect on the insulation. To remove the outer metal cable armor, you should use a tool like the one shown in this figure, or a hacksaw as shown on the figure beside. To cut through one of the raised convolutions of the cable armor. Do not cut too deep or you will cut into the conductor insulation. Then bend the cable armor at the cut. It will snap off easily, exposing the desired amount of conductor. To prevent cutting of the conductor insulation by the sharp metal armor, insert an anti-short bushing at the cable ends. Both non-metallic sheathed cable and armored cable have advantages that make them suitable for particular types of installations. However, the type of cable to be used in a specific situation depends largely on the wiring method permitted or required by the local building code. Installing cables through wood or metal framing members. To complete the wiring of a residence, you must run cables through studs, joists, and rafters. One method is to run the cables through holes drilled at the approximate centers of wooden building members, or at least 32 mm from the nearest edge. Holes bored through the center of standard 2x4 meet the requirements of Rule 12-516. Where cables in certain types of raceways are run concealed or exposed parallel to a stud, joist, rafter, or other building framing member, the cables and raceways must be supported and installed so that there is at least 32 mm from the edge of the stud, joist, or other framing member to the cable or raceway. If the 32 mm clearance cannot be maintained, a steel plate, or equivalent at least 1.59 mm thick must be used to protect the cable or raceway from damage that can occur when nails or screws are driven into the wall or ceiling, Rule 12-516. This additional protection is not required when the raceway is rigid metal conduit, rigid PVC conduit, or EMT. Additional protection. The logic is similar to the exception that permits non-metallic sheathed cable to be fished between outlets without requiring subports as stated in Rule 12-520. The recreation room of this residence requires adequate protection against physical damage for the wiring. The walls in the recreation room are to be paneled. Therefore, if the carpenter uses 1x2 or 2x2 furring strips, non-metallic sheathed cable would require the additional 1.59 mm steel plate protection up the walls from the receptacle outlet and switch. This could be quite costly and time-consuming, and a good case could be made for doing the installation in EMT. Watch out for any wall partitions where 2x4 studs are installed flat, as shown on the other figure. In this case, you can either provide mechanical protection as required by Rule 12-516-2 or install the wiring in EMT. Steel framing is used in a wide variety of residential applications, including single and multi-dwelling buildings. The framing is galvanized sheet steel that is pre-punched to accommodate the installation of electrical and mechanical piping and cabling. Steel framing is used for non-structural, light gauge, and structural, heavy gauge applications. When installing metal boxes on steel frame you can use self-piercing screws on light gauge framing, but self-drilling screws will be required on heavy gauge framing. A minimum of 3 threads should penetrate the framing. Steel studs do not provide as much support as wooden studs, therefore, extra support must be provided to prevent movement of the box after the drywall has been installed, Rule 12-30-10. When running NMSC through metal framing, you must protect the cable from mechanical injury by an approved insert where it passes through a framing member, Rule 12-516. Installation of cables in attics. Wiring in the attic must be done in cable and meet the requirements of Rules 12-500 through 526 for non-metallic sheathed cable. In accessible attics, as it shows in Part A of this figure, cables must not be installed across the top of floor or ceiling joists as shown at number 1. Run across the face of studs as number 2. Or rafters as shown at number 3. That have a vertical distance between the floor or floor joists exceeding 1 meter. Guard strips are not required if the cable is run along the sides of rafters, studs, or floor joists as shown at number 4. Provided Rule 12-516, 1 and 2 is met. Part C of this figure illustrates a cable installation that most electrical inspectors consider to be safe. Because the cables are installed close to the point where the ceiling joists and the roof rafters meet, they are protected from physical damage. It would be very difficult for a person to crawl into this space, or to store cartons in an area with a clearance of less than 1 meter as shown Part B of this figure. Although the plans for this residence show a 600 mm wide catwalk in the attic, the owner may decide to install additional flooring in the attic to obtain more storage space. Because of the large number of cables required to complete the circuits, it would interfere with flooring to install guard strips wherever the cables run across the tops of the joists. However, the cables can be run through holes bored in the joists and along the sides of the joists and rafters. In this way, the cables do not interfere with the flooring. Note that most building codes will not allow manufactured roof systems to be drilled. This includes roof trusses. When running cables parallel to framing members, maintain at least 32 mm between the cable and the edge of the framing member, Rule 12-516, 1 and 2. This minimizes the possibility of driving nails or screws into the cable. Installing cables through ducts. Rule 2-128 is strict about what types of wiring methods are permitted for installing cables through ducts or plenum chambers. These stringent rules are for fire safety. The CEC permits type NMD90 cable to be running board installed in joist and stud spaces, example, cold air returns, in dwellings. It recommends that type NMD90 pass through such spaces only if the cable is run perpendicular to its long dimensions. Connectors for installing non-metallic sheathed and armored cable. The connectors shown in figure are used to fasten non-metallic sheathed cable and armored cable to the boxes and panels in which they terminate. These connectors clamp the cable securely to each outlet box. Many boxes have built-in clamps as shown in C and do not require the separate connectors. Knockouts and pryouts on the sides of boxes allow installation of cables and connectors as shown in figure D. Unless the CSA listing of a specific cable connector indicates that the connector has been tested for use with more than one cable, the rule is one cable, one connector. Electrical metallic tubing and rigid metal conduit. In a building constructed of cement block, cinder block, or poured concrete, it is necessary to make the electrical installation in conduit. According to the CEC installation requirements, EMT and rigid metal conduit may be used for open or concealed work. May be buried in concrete or masonry with certain provisions. May be used in combustible or non-combustible construction. In general, EMT must be supported within 1 meter of each box or fitting, and at 1.5 meter intervals along runs for 16 mm and 21 mm conduit. Heavy wall rigid conduit provides greater protection against mechanical injury to conductors than does EMT, which has a thinner wall but is more expensive. The residence specifications in this text indicate that a meter base is to be supplied and installed by the electrical contractor. Main panel A, a combination panel, is located in the workshop. The meter base is located on the outside of the house as indicated on the electrical plan. The electrical contractor must furnish and install a 53 mm rigid PVC conduit between the meter base and main panel A. Rule 12-906 requires that insulating bushings or equivalent be used where number 8 or larger conductors enter a raceway. Also, if rigid metallic conduit is used between the meter base and the combination panel, bonding type bushings must be used on the service entrance conduit. The plans indicate that EMT is to be run from the workshop to the attic. Properly installed EMT provides good continuity for equipment bonding, a means of withdrawing or pulling in additional conductors, and excellent protection against physical damage to the conductors. Rigid PVC conduit. PVC conduit is easily handled, stored, cut, and joined. It is commonly used for service entrance conduit in residential services in both overhead and underground applications. Easy to work with, it provides as a rigid, watertight conduit for the consumer's service conductors. When joining PVC to a fitting, you must cut, ream, clean, and glue the conduit. To cut PVC, use a hacksaw. For larger sizes of conduit, use a miter box so that the cut is square. Measure twice, cut once. After cutting PVC conduit, ream out the burrs with a knife and clean the end of the pipe and inside of the fitting with an approved PVC pipe cleaner. Then apply a liberal coat of solvent cement to both surfaces, slide together, and give a quarter turn to make sure the solvent is spread evenly on the material. Hold together for a few seconds, and the joint is made. See part A and B in this picture. Do not use an open flame to bend PVC, Rule 12-1108 instead, use an approved heat gun, heat blanket, or other flameless heat source to heat the pipe to about 125 degrees Celsius as shown on part C and D. Always heat an area of at least 10 times the diameter of the conduit before attempting to bend it. If not heated enough, the pipe will kink or collapse. When you make a 90 degrees bend, the center radius of the bend must meet the minimum radius requirements of Table 7, Rule 12-924. Thus for 16 mm conduit the minimum radius is 102 mm. If the radius is 10 times the internal diameter, it is a lot easier to fish and pull in wires after the conduit is installed. Draw a template of the bend first, and then heat the conduit and shape it to the template, as shown in Part E. To provide adequate support for the conduit system, you must use proper straps. The two-hole strap in this figure, Part O, allows the conduit to move as it expands or contracts. Never clamp the conduit tightly, Rule 12-11-14-3. The spacing for supports is about half the distance for other types of conduit, therefore twice the number of straps are needed. See Rule 12-1114 for maximum support spacing. Rule 12-11-18 give a formula for calculating the linear expansion of various materials. Since PVC has one of the highest coefficients of linear expansion, check that the maximum expansion of the conduit due to temperature change will not exceed 45 mm, Rule 12-11-18. And here it is example on how to use this formula. Flexible connections. Some equipment installations require flexible connections, both to simplify the installation and to stop the transfer of vibrations. In residential wiring, flexible connections are used to wire attic fans, food waste disposers, dishwashers, air conditioners, heat pumps, recessed fixtures, and similar equipment. The three types of flexible conduit used for these connections are: flexible metal conduit, Part A in the figure. Liquid-tight flexible metal conduit, Part B in the figure. Liquid-tight flexible non-metallic conduit, Part C in the figure. This figure shows types of connectors used with flexible conduit. Part A shows fittings for flexible metal conduit. Part B shows fittings for liquid-tight flexible metal conduit. Part C shows fittings for liquid-tight flexible non-metallic conduit. Flexible metal conduit. Rule 12-1002 covers the use and installation of flexible metal conduit. This wiring method is similar to armored cable, except that the conductors are installed by the electrician. For armored cable, the cable armor is wrapped around the conductors at the factory to form a complete cable assembly. Figure shows some installations that commonly use flexible metal conduit. The flexibility required to make the installations is provided by the flexible metal conduit, and a separate bonding conductor is required. Summarizing Rules 12-1002 through 1014 concerning flexible metal conduit. Do not install in wet locations unless the conductors are suitable for that use, RW90, TWN75. Ensure that water will not enter the enclosure or other raceways to which the flexes connect. Do not bury in concrete. Do not bury underground. Do not use in locations subject to corrosive conditions. Do not use the metal armor of flexible conduit as a bonding means. A separate bonding conductor must be installed inside flexible conduit, Rule 12-1306. Runs of 12 mm trade-size flexible metal conduit are not permitted to be longer than 1.5 meter. Support conduit every 1.5 meter. Support conduit within 300 mm of box, cabinet, or fitting. If flexibility is needed, support conduit within 900 mm of termination. Do not conceal angle-type fittings because access will be needed when pulling in wires. You may use conduit for exposed or concealed installations. Use fittings approved for use with flexible metal conduit. Liquid-tight flexible metal conduit. The use and installation of liquid-tight flexible metal conduit are described in Rules 12-1300 through 1308. Liquid-tight flexible metal conduit has a tighter fit to its spiral turns than standard flexible metal conduit, as well as a thermoplastic outer jacket that is liquid-tight. It is commonly used as the flexible connection to a central air conditioning unit located outdoors. Liquid-tight flexible metal conduit may be used for exposed and concealed installations. May be buried directly in the ground if so listed and marked. May not be used where subject to physical abuse. May not be used if ambient temperature and heat from conductors will exceed 60 degrees Celsius unless marked for a higher temperature. If 12 mm trade size is not permitted longer than 1.5 meter. Must have the same conductor fill as regular conduit, Rule 12-1014. Must have conductor fill for 12 mm size based on cross-sectional area of 118 mm square, Rule 12-13042. Must be used only with approved fittings. Must not be used when flexing at low temperatures will cause injury. Must not be used as general-purpose raceway. Is not acceptable as a grounding means. Must not have concealed angle-type fittings. Liquid-tight flexible non-metallic conduit. Summarizing CEC rules pertaining to liquid-tight flexible non-metallic conduit. Do not use in direct sunlight unless specifically marked for use in direct sunlight. You may use it in exposed or concealed installations. It can become brittle in extreme cold applications. You may use it outdoors when listed and marked as suitable for this application. You may bury it directly in the earth when listed and marked as suitable for this application. You may not use it where it might be subject to mechanical damage. You may not use it if ambient temperature and heat from the conductors will exceed the temperature limitation of the non-metallic material. 12 mm trade size is allowed for enclosing the leads to a motor, Rule 12-13022. Conductor fill is the same as for regular conduit, Tables 6A-6K, Rule 12-1014. It must be used with approved fittings. A separate bonding conductor is required and should be sized with reference to Table 16 and installed according to Rule 10-614.